So
we begin. We're not so many people, but we'll begin anyway. It's the end of the end, and
yeah.
Have to be happy for every person who's still here at this time.
Yeah, I think everyone is just gone around the city to see Sydney.
Yeah, before the long
before
trip
going
away.
home.
I'm George Offord, work for Ericsson, have had some dealings with Fraser from my company and people on his team, and a whole long complicated development process that started last year, bit on and off. And the PTL is Saad.
Yeah, hello, I'm Saad Zahir. I work for Hewlett Packard in Ireland. We're a small team. We used to work in OpenStack and Helium. We used to do delivery of cloud development and lots of things in my team. So currently my team is focused in many areas. So we do Kubernetes, Docker, lots of containers and stuff, and we're still doing OpenStack, as well as blockchain and other set of stuff we're really doing right now. So today we're going to give an update about what we have done for the Pike release for Fraser and what's going to be next, hopefully. Okay, so first, I would like just to give an idea what is Fraser, what's our scope, and what we meant to do. Fraser is a distributed backup and restore and disaster recovery system or a service platform which allow you and your user to take a backup and restore your data. It is a platform independent. We used to have Fraser running on Windows, on Linux, and Mac. It runs on really different operating systems, and it supports block-based backups and file-based backups, and it supports incremental and full backups. So it does lots of bunch of stuff in Fraser. Fraser has been here for like 3 years now on OpenStack. It has been like 3 years in the big tent. Lots of people are using Fraser, but no one files like use cases and all that kind of stuff. I don't know why, but lots of them are using Fraser. Big names are using Fraser in production, and lots of them are using Fraser disaster recovery just to keep their cloud alive. And we have done lots of experiments and deployments for Fraser in production, and it's really doing good. So we're going to talk about Pike features. I don't know if everyone knows or aware Fraser, we have a concept of engines. The engines are sort of component in Fraser which allows the Fraser ecosystem or Fraser system to take a backup of a certain resource. So in Pike release, we added a dedicated Nova engine, which allows you to take a backup of your instances running in the cloud. For example, if you have an instance and you would like to backup this instance to an SSH host or to a Swift or to Ceph or to local storage or to whatever, you can use this Nova engine, which is going to efficiently take a snapshot from your instance and stream it to your storage. So we don't really download it, we just stream everything. So this was one of the features we added in Pike release. The second feature is a Cinder OS break engine. The Cinder OS break engine is another Cinder engine. We actually do have 3 Cinder engines. The first one is just using or making use of the scheduling mechanism in Fraser, which allows you to trigger a Cinder API calls to backup your Cinder volume. The second one is triggering a Cinder API call, which is snapshotting your Cinder volume and download it, stream it to your storage. It just takes a snapshot and upload it somewhere else. The third one allows you to mount the volume remotely, take a file system backup of your Cinder volume, release the volume, and upload your backup somewhere else. So this could be the most efficient in some use cases, some might not. So we should be satisfying all the needs for Cinder with this feature. Also, we supported in Pike rsync incremental backups version 1, which we used to have rsync with some Python calculations and all this kind of stuff, which wasn't really that efficient. It was pretty slow. So we had to implement another rsync incremental backups version 2, which supports more native calculations with the rsync engine, which makes things more faster and more efficient. So
I was just wondering if everyone here is understanding the mechanism how it's taking the backups, because it's involved. The rsync is a crucial part of what made it more efficient over the standard way of doing it. But I don't know if this is clear for everyone how it actually does it.
yeah, well, it should be clear, or we can address this maybe in a different video or
No.
something.
I
don't know.
Curious. Everyone understands? No.
Okay, you want to give some dates?
Off my head. What's the idea with the agents? So the difference
Well,
with how it's done altogether.
yeah, the idea is we have the rsync is synchronizing your data from one location to another location. So we were using it's a command line in your Linux, and it's a tool, so you can use it. So the idea, we were using version 1, which we were heavily depending on Python to do calculations of lots of blocks and stuff,
Right.
to calculate which block to backup and all that kind of stuff. Then the second one, we were really using different tools to do the calculation, so which made things more faster. Python is a great tool, but it might be a little bit slow in some areas, so we had to revoke and use other stuff, which was really faster. We also do have a video which is demonstrating the rsync engines, so you can go and check these videos. It shows you how to use Fraser to backup using rsync and differences between version 1 and version 2 and all that kind of stuff. It's all available in YouTube. We might send this to the mailing list. It's already sent. We can resend it again so people can make use of it. Also, yeah, we introduced in Pike another feature, which is, we think it's going to be a really great one, which is tenant backups. Tenant backups, it is a kind of, okay, I am a user to a tenant, and I would like to take a backup of all resources of my tenant. So we introduced what's called a tenant backup. So for tenant backups, you can now go and say, okay, Fraser, I would like to back up all the resources of my tenant. Fraser will go, snapshot all your instances, back it up somewhere. You choose, you configure your job, where do you want to back up your tenant. It back up your resources one by one and uploads it to your storage. And then if you want to restore all these workloads, you can just with one click or one job, you can restore all the workloads again to another empty tenant. So with this, if an administrator would like to have a backup or wants to move a workload from one cloud to another cloud, it could be easily back up your tenant, download the files, upload it somewhere else. Everything's working out of the box, and it's just working, you know. Also, tenant backups, we don't really fully back up everything in the cloud. Like we back up some resources. That's why we're going to do more work to back up a lot of more resources in the future. Also, we introduced in the API side, API version 2, which is still experimental. The API version 2 supports out-of-the-box multi-tenancy. We weren't really supporting multi-tenancy. Now we fully support multi-tenancy in Fraser, so every user has his own dedicated way of dealing with Fraser. So multi-tenancy is now fully supported and fully functional in API version 2. It might need a little bit of testing and a little bit of enhancement. That's why we're setting this under experimental, and maybe by end of Queens, yeah, we're going to move it to stable, and we're going to deprecate version 1, which doesn't support multi-tenancy at all. So with this, I think we're going to be really more interesting, because users can schedule their own backups, can schedule their own jobs, and Fraser might be more functional and more useful for everyone. Oh, okay, sorry. So for Fraser DR, lots of people, they don't know about Fraser DR, which is a part of Fraser and a part of the core business we have in Fraser. We enhanced the core monitoring layout of Fraser DR. Fraser DR is meant to be a disaster recovery component in Fraser, which cares about your compute node. compute nodes, it provides a compute node high availability. So you set up Fraser DR. It could be within the cloud. It could be outside the cloud, which is a good thing. You don't need a special setup for your cloud to do disaster recovery with Fraser DR. It could run from outside and still can do the job for you. So we enhanced the core monitoring system in Fraser DR. So we can add easily more monitoring systems, which could be more flexible, can do more, can do the monitoring in different and many ways, which gives more flexibility for the users to pick up their own monitoring system. For you who doesn't know what Fraser DR is, it consists of 4 layers. The monitoring layer, which is monitoring your compute nodes, and if your compute node is alive or is okay, if it went down, it's going to report this to Fraser, which is going by its turn to move it to layer 2, which is setting this compute node in maintenance mode and then disable it, then fence it, then it's going to evacuate all the workload from this compute node to another one, then notify your administrators so you keep track of what's going on in your cloud. We're not a component which you can go and we do fencing and we move your workload without notifying you. So that's why we have 4 layers: monitoring, fencing, evacuation, and notification. Also in Fraser DR, we enhanced the Monasca driver, which is one of the greatest driver we have in Fraser DR. Well, Fraser DR, developed by people working in Helion, so we were shipping Monasca with Helion, so we fully integrated with Monasca. That's why we have a main Monasca driver, like one of the core drivers is the Monasca driver. So the Monasca driver, we enhanced Monasca driver a little bit so we can give the user more space to pick what he really wants to monitor, how he's going to do the monitoring. All this can lie in the configuration file. So in your configuration file, you specify how do you want to monitor your compute nodes, and we just do it for you.
Question.
Yeah.
Question.
Yeah, sure.
Do you still have a Fraser scheduler?
Yes, we still.
Okay. How often can you schedule your backups? How often can you schedule the information you would need for your disaster recovery? Is that like? Yeah,
the scheduler, the monitoring, how often do you want to monitor your compute nodes? It is defined in Fraser DR itself, not in the scheduler. So you define in your configuration files how often do you want to monitor your compute nodes, and even you define how do you want to judge. Like the default way is we monitor your compute node and then we give grace time, like we wait a little bit for like, you say, okay, wait 10 minutes, wait 5 minutes. It depends on your business decisions. Then we move, okay, we do another round of monitoring. Maybe it was someone restarting some stuff. Maybe something was just crashing and then it went up again. Then we do another round of monitoring. If we found anything down or the same thing is still down again, then we say, okay, something is wrong.
Okay.
So that was the main Pike features we had so far. So this is like part of the features. We still have tar engines. We still have lots of features which we're not stating over here because this is meant only as an update for Pike. So we have lots of stuff which is not here yet. So for Queens, for those of you who's using Fraser, Fraser depends on Elasticsearch, which we're going to really move from this to OsloDB, and there's a patch right now in review to move Fraser from Elasticsearch to OsloDB. So we're going to use MySQL and Postgres and all SQL-like databases, which make the installation and configuration of Fraser way easier than it's now. We're going also to do a little bit of enhancement for tenant backups. So we're going to add more resources to be backed up using tenant backups. For example, neutron networks. We're going to back up neutron networks. So before we relaunch the instance, we're going to create the network, and we won't ask you to provide us with a network ID. Security groups and all this is going to be backed up with the tenant backups. So we're going to take a really full backup of a tenant and move it somewhere. Enhance the multi-tenancy. A little bit of enhancement in the multi-tenancy because we're moving to OsloDB, so we're going to do a little bit of enhancement and a little bit of changes. Also to fulfill with Queen's goals, we're going to do all this in enhancing the multi-tenancy. Disaster recovery. For Fraser DR, we're going to add more monitoring drivers. We actually have a monitoring driver right now in progress, which is using different monitoring system, not Monasca, to monitor applications running in the cloud and instances running in the cloud. So we're going to add more, which is going to monitor a single VM or a set of VMs or a certain application which combined of a couple of VMs or more in your cloud and move it somewhere else or evacuate it. So what we're going to do beyond Queens. Remote backups, which is one of the most interesting stuff. For the time being, if you want to take a backup of a virtual machine or some workloads inside a virtual machine, you need to install Fraser Engine using Cloud Init in your virtual machine while creating it. Like this, if you want, for example, to take, say you have a database server running inside a virtual machine and you want to take a backup, you just go to Cloud Init and say pip install Fraser, which is going to install Fraser and then can send jobs to this virtual machine and back up your resources. With remote backups, you can use the agent which exists outside your virtual machine to back up workloads and stuff inside your virtual machine, which is going to be, hopefully, by end of Queens or beyond Queens. More database engines to support. We're actually thinking of keep Elasticsearch, keep the driver for Elasticsearch. It's not going to be the main driver, but we're just going to keep support. If you want to use Elasticsearch, it's up to you. You continue using Elasticsearch. The main one will be OsloDB, and maybe we're going, OpenStack now officially supports etcd, where we're going to support or to have a driver for etcd as well. So we're going to support more database engines. We're going also to implement, hopefully, a backup data API, data endpoint in the API. So the API itself now acts as a scheduling gateway or something like that. So you just submit your jobs to the API or fetch your jobs from the API and so on and so forth. For in future, hopefully, we're going to add an API, an endpoint in the API where you can submit some data, and the API takes care of distributing this data somewhere. And by this, we're going to move the logic of Fraser from Fraser itself to Fraser library, where we can have the core logic in a sort of library, and then we can have Fraser agent implementing this library. We can have this library implemented somewhere in the API or another endpoint. So this Fraser library, you can even take it outside OpenStack and implement it somewhere and implement your own way of taking backups and your own way of doing backups and restore. So it could be like that. So this is what we hope to implement beyond Queens. And for disaster recovery, we actually would like to have a combined or complex monitoring drivers. Like we say, okay, I have Monasca and I have Nagios monitoring systems, and I would like to have a decision from both, not only one driver to judge my compute nodes are down. So we would like to have a combined decision from both of these drivers. If one says it's down and the other one says it's not down, probably it's not down. So, or probably the monitoring system has something wrong. So we're not going to rely only on one monitoring system. It's going to be more complex to give more flexibility or more reliability. Yeah, disaster recovery as well. We're going to implement a kind of database. Currently, we're storing the state in our log files. Like you have the log files, which is compatible with Oslo logging, so you can upload it to a logging system and check it. But we would like to have a database for coordination and storing the state of your cloud, what really happened, how did it evacuate, and all that kind of stuff. And this, hopefully, for the time being, this is what we're planning for beyond Queens. Also, how do you want to give us a feedback? Unfortunately, we didn't have any feedback session here in Sydney so far. So what you can do, you can send an email to the mailing list with Fraser in the subject, and we're going to reply this email. And we're going to help you as much as we can. Or you can check and come to us in the IRC channel, which is OpenStack-Fraser, and you're going to ask a question, and you'll find lots of people replying your question. We have lots of people laying around answering questions. I was just off for like a month. That's why I wasn't answering any questions, so sorry for that. How to contribute and how you can find us. So the first link explains to you how can you contribute to OpenStack. The second one is links where you can find Fraser codes. And hopefully, also what I forgot to mention, one of the main achievements we had in the Pike release, I forgot to mention this, which is documentation of Fraser. Before, we didn't have any Fraser documentation at all. Now, you can find Fraser documentation. It is published on OpenStack website. So it's docs.openstack.org/Fraser. You're going to find Fraser documentation. And you can really, it's the second link. You can see it. This is the documentation. You can see all the documentation, how you can install Fraser, development guides, how can you work with Fraser, configure it, and all these things. It's all available here in the second link.
I'd like to say something here about the whole idea of contributing. It's been a tough time lately, this last year, about contribution generally speaking, not just Fraser, but everywhere. A lot of companies have disappeared, and I work for telco, and they're very shy about putting their foot in the water. And this is a very important area. There's been a SIG on at this meeting in Queens this year. I mean in Sydney, here at the summit this year, because topics such as backup and restore and disaster recovery are really important. And we've reached a level of maturity in the cloud, in OpenStack, where everyone is going towards production now in a big way. And it would be really good to get this together and momentum behind it before any big bang should happen anywhere. And yeah, God forbid that should happen. So contribution is the number one. I fight for it all the time. That's my actual job title. You know, I work to get people to work upstream. It's not easy, but this is a worthwhile project. The guys from my company who were working with his guys, they're really good people. We had a lot of fun. Everything was going good. There was a lot of push. And then came the big, you know, budget. And unfortunately. But 2018 is the year it's going to happen. So use the links. If you know anyone who can or will, they won't regret it.
Also, we would appreciate if you have any comments or any bugs available for documentation, because we just published this, so we don't know if you find any bugs. Just let us know. You can file a bug, like you'll find a link in the documentation itself where if you found a bug, you can just click on a bug icon where it will take you to Fraser project where you can file a bug and let us know. And now Q&A, questions. Any questions? Yeah, sure.
Now that you have multi-tenancy, would you say Fraser is okay to go for a public cloud?
Well, Fraser, yeah, well, it's a tricky question, to be honest. If you want to go to public cloud, it depends on your design. How do you want to design your stuff? How do you want to design your backups to be taken? Because you now give the users the flexibility to upload their backups somewhere. So probably in your public cloud, you care about bandwidth. So you don't want to give a user a tool where you can say, okay, I can upload this here, there, and all that kind of stuff. So maybe you can use Fraser in a public cloud, and we have a use case where some users used it for a public cloud. Some people used it for a public cloud, but they were kind of using it for operators, like operators in multi-tenancy and like taking backups of the cloud itself and all that kind of stuff. Operators were using Fraser. I think after moving to multi-tenancy, we have a very good separation between users, so you can take backup. And also, if you're going to forbid users from uploading backups to SSH host, or they're going to upload to Ceph or Swift, or Ceph or Swift, so you can limit from Fraser and from Ceph and Swift as well. So the user can only upload a backup from his workloads to Swift or from his workloads to Ceph.
Well, if I understand right, it's basically a business model.
Yes.
I mean, if you want to sell backup as a service and put a number on it, then those people who find it interesting, which will also restrict them what they're going to actually back up, because it won't be free. So
Yes, I think a short answer is yes. So you have a policy files, and we're going to implement the Pi as a Queen's goal, which is policy in code. So by changing the policy, you can limit the users what they can really do and what they can do. So with all these features, multi-tenancy, limiting users using policy, I think you can use Fraser, because the engines, we're trying to develop Fraser agent as something stupid who doesn't understand really much about what Fraser is doing. It is something you ask him and instruct him, do a backup. It says, okay, I did a backup, here it is. Restore a backup. It says, where is your backup? Here, okay, here it is. And all the logic we're trying to add it to in the jobs and in the scheduling and all that kind of stuff, so we can move this and change this using policy files, using coordination, and all the tools that the admin can change and can easily maintain. Because also, if Fraser is down and if the API is down and you're taking your backups outside your cloud using an SSH host, using only Fraser agent, you can restore your cloud. And we had a cloud for a big customer who was trying to use Fraser agent or Fraser to restore his cloud if something went wrong and if the cloud is destroyed. So simply, the customer had 3 controllers. The 3 controllers, we took them all of them down, and we left the compute nodes running. Before we take the 3 controllers down, we took a backup from using Fraser from these controllers, like from the database and some other directories and all that kind of stuff. Then we redeployed the controllers after taking them down. We redeployed them, so the cloud looks now fresh and new. Then we used Fraser to restore all the backups, then restarted some services on the controllers. Then the state of the cloud was as it is, like as before we take the controllers down. And we didn't have Fraser API, we didn't have a job, we didn't have anything. And the new Fraser API is not aware of the backups taken before. So using only Fraser agent, you can restore your previous state of your cloud again. So I think with multi-tenancy and policy, you can do public cloud. And with Fraser agent only, you can restore your cloud if there is a disaster. With Fraser agent, you can do compute nodes, high availability, if something goes wrong. Other questions? Okay, thank you everyone, and have a great day. Thanks.
Yes, yes.
Thank you.
Yes. Thank you.